We love using our 3D printers and DIY tools to bring out the absolute most from our gear. A few weeks ago, I promised a massive quality of life upgrade for this premium Toocaa L2 laser. And yes, it involves 3D printing as well. But I have some bad news. Some of the things I might have told you to buy in preparation for this, well, they won't be needed. The good news? That sensor was the most expensive item on the list. The final modification is actually much simpler, cheaper, and easier to build, but getting to this simple solution involved days of testing, drilling, and a massive facepalm moment that I just have to show you. Stick around and I'll give you the complete hardware and software recipe to finally make your laser's air pumps fully automatic. No more forgetting to turn on our fume extraction or air assist. I'm gerGO, and this is gerGO Print 3D, the YouTube channel about our adventures with 3D printers, laser devices, and adjacent technologies. My nephew Levi is away skiing this week, but this would be a bit too much wiring for him anyway. But, as always, this video includes curated, translation-ready subtitles, detailed chapter markers, and audio tracks in multiple languages to help you follow along. If you saw our full review of the Toocaa L2, you know I genuinely love this machine. It feels premium, it's enclosed, it's safe, and it's incredibly effective. But it has one quirk that drives me crazy. You have to manually turn on the air assist and the smoke purifier every single time. I promised you back then that we would fix this, and today we are delivering on that promise. If you are looking for a top-tier diode laser, check out the affiliate links in the description. With our code, you can get the best price on the Toocaa L2, and it supports the channel so we can keep doing mods like this. But before we start cutting wires, a huge shout out to our sponsor, PCBWay. We are doing a lot of custom electronics work today. While we are wiring this prototype point to point, a cleaner version 2.0 would definitely use a custom printed circuit board to make it compact and professional. Whether you need rigid flex boards, aluminum substrates for heat dissipation, or just standard high-quality PCBs in a rainbow of color options, PCBWay is the industry leader. They also offer CNC and 3D printing services, but for electronics projects like this, they are my absolute go-to. Check out their offers using the link in the description. To figure this out, I raided AliExpress. For projects like this, I picked up this very capable bench power supply you've seen in our chocolate video already, a handheld oscilloscope, a soldering station, and the components for this particular mod, a solid state relay, a wall socket, that photocell we ended up not needing, and this HY 2.0 plug that fits the laser's expansion port. You'll also need micro switches. I put links to all these affordable tools and parts in the description. They are great to have for any workshop. And yes, even that photocell, I'm sure it will come in handy for a future project. You'll see. But not yet. Yes, my original plan was to use this NPN photocell to detect the laser head. On the bench, connected to the power supply, it worked perfectly, swinging from 0 to 24 volts when triggered. I also tested the solid state relay. It turned on. But remember, these need an AC load on the output side to actually latch and function properly. That fooled me first, but then I was happy to see that adding 24 volts DC on its input allowed the flow of 220 volt AC on its output. It all seemed like a great start for this project. So we'll need 24 volts to operate these, and I already knew we could get this power from the second unused EXT port of the L2. I figured out that this port, located on the inside of the front frame, connects using a 14 HY 2.0 plug. I quickly found the ground and plus 24 volts on the black and red wires. They are the two pins closest to the next currently unoccupied Z port, which we will use for the rotary accessory in a future update video. As for the blue and yellow wires, I measured 3.2 volts on them, and I was kind of hoping they would be some kind of simple signal wire that indicated when the laser was operating. Or better yet, when the air assist G code was triggered. But no, after a quick check with my new O1 oscilloscope on these two pins, I got this gibberish. It's UART data. We won't make sense of this. So our next best bet is to use a physical trigger powered by that 24 volt rail. Because I'm dealing with mains voltage, a safe enclosure wasn't optional. I used this smart socket project as my first major trial with FreeCAD 1.0 after moving away from Fusion 360. The design features internal mounts for the relay and top mounts for the wall socket. We'll use heat-set inserts and screws for fastening these. For safety, I separated the enclosure into low voltage and high voltage zones. One side has a small entry for the sensor's control wire, while the opposite side handles the heavy AC cable and its internal routing for ground and neutral connections to the socket. I also added vertical ventilation slots along the sides to ensure passive cooling for the relay during operation. To finish it off, I cut a viewing port into the lid, which actually acts as the bottom of the case, so I can check the relay's status LEDs at a glance. You will see why that was such a vital feature. I printed the first prototype out of green Sunlu PLA on our FLSUN S1 Pro. That machine is incredibly fast for drafting. It needs no lengthy preprint routines and printed the lid in just 15 minutes, allowing me to confirm that the wall socket matched the box's footprint perfectly for stacking. The rest of the box also printed in less than an hour, about twice as fast as our other printers. Once I confirmed the dimensions were perfect and all the screw holes lined up, I uploaded the STL files to my Call 3D page so you can download them too. For the final unit, I switched to the Chidi Q1 Pro to print in white G-Tech ABS. Since this box might get warm and lives near a laser, ABS is the safer choice. That's cool. I did forget to apply glue to one corner of the bed, so it curled a tiny bit, but otherwise the ABS prints beautifully in this heated chamber machine. I chose the Q1 Pro because it's the smallest printer we have with a heated chamber that fits these parts. It's much more efficient than heating up the massive build volumes of our SVO8 Max or Creality K2 Plus for a project this size. Finally, as a recurring theme on the channel, I used the DIY stealth press we made 2 years ago to install the brass heat-set inserts. If you haven't built one of these yet, check out my video on it. It makes assembly so much more precise and satisfying. Now came the point of no return. I needed to route the low voltage wire out of the laser chassis. For this, I used our Hotto 16 volt brushless drill to make a hole in the backplate. Aluminum shavings and lasers definitely do not mix, so to catch the dust immediately, I used our AutoCare Mini vacuum from the same brand. It's incredibly handy for keeping the workspace clear during mods like this. I wired the photocell to the 24 volt power rails from the EXT port, routed it through the new hole, and connected it to the relay control input inside our new box. It looked clean. It looked professional. Using double-sided tape temporarily, I positioned the photocell precisely. As you can see, the red and green indicator LEDs turn on as expected as I move the gantry from light burn. Yes. Let's check the relay. I was careful to test things first without connecting AC power. And the indicator on the relay, it did not light up.
No, it did
What's
not.
wrong? I quickly measured the input from the photocell. There is signal, but only 1.6 volts. What the heck? On the bench, the photocell output was 24. I disconnected the relay and measured just the output again. We have the 24 volts.
24 watts.
But it collapses to just 1.6 volts as soon as we hook up the relay.
Interesting.
I spent hours debugging this. Was the laser port too weak? Was the relay dead? It turned out the sensor itself was the culprit. It had a high impedance leakage that couldn't sink enough current to drive the relay properly. I had over-engineered it with a fancy sensor and it failed completely. If you appreciate me spending 3 days failing so you can succeed in just 3 minutes, please hit that like button and subscribe. It really helps the channel grow and lets us keep making mistakes so you don't have to. So I went back to the basics. If the port has 24 volts, but the electronic sensor is the bottleneck, let's just remove the bottleneck. I swapped that fancy sensor for a mechanical microswitch that cost a few cents. The logic is identical, but the physics are different. Instead of a chip trying to drive the current, the switch just physically breaks the positive wire. When the laser is at home, it presses the switch. Opening the circuit, pumps off. When it moves away, even just a few millimeters, the switch releases, closing the circuit, pumps on. It doesn't consume amperage, it just lets it flow. To mount this, I needed a precision hole right near the y-axis gantry. For this delicate work, I used the Hotto snap block precision drill. This tool system is fantastic for small electronics like this, and I actually have a 15% discount code for Hotto tools in the description if you want to grab a set for yourself. I wired the switch directly in line with the 24 volt positive wire coming from the EXT port leading out to our 3D printed relay box. And look at that, simple, reliable, mechanical. There is one final piece to the puzzle, software. With the switch installed, the pumps turn on instantly when the laser moves away from home, starting the job. But there is a catch. We want that air assist pump to build up pressure before the laser fires. And we want the fume extractor to keep running for a few seconds after the job is done to clear the last bit of smoke. We can solve this easily in Lightburn. Under device settings, go to Start G-code and add the commands you see here. This tells the laser to move away from the starting position and dwell or wait for 5 seconds before starting the job. Then, in the end G-code section, we ensure the head moves slightly away from the switch, followed by G4, P10. This keeps the fans roaring for 10 seconds after the cut is finished, before the machine goes home and shuts everything down. We already had this mod set up when we cut this miniature székely kapu, a beautiful and monumental hand-carved wooden gate typical of Hungarian villages in Transylvania that features elaborate folk motifs and a distinctive dove cut, making it a deeply cherished cultural treasure that is very close to the heart of every Hungarian, so it makes a great gift for your Hungarian friends. Watch closely. I hit start. The head moves just a few millimeters away from home. Click, the pumps roar to life. The laser waits 5 seconds for the airflow to stabilize, and only then does it begin cutting. While you watch the machine effortlessly engrave and chew through this plywood, let me remind you why I love this Toocaa L2. It is our most premium field laser, the one I keep in my living room. It produces no smell thanks to our sealing upgrade and the strong smoke purifier included in its advanced and higher tier bundles. It is safe with all the interlocks, flame and tilt sensors, and now with this automation mod it operates like the well-tuned precise instrument it is. If you want to grab one, please use our affiliate links in the description. With our code, you get a substantial 10% discount, and we get a small commission that helps fund these kinds of projects. When the job finishes, notice that the pumps stay on, clearing out every last whiff of smoke. Then the gantry travels all the way back home, hits the switch, and silence. So satisfying to watch. This mod completely transforms the user experience, but we aren't done with the Toocaa L2 yet. We still have that rotary attachment to show you. Heck, it can do so much that we'll need some more time to explore everything. We also have more electronics heavy projects coming up, including one that fixes a problem with our American bamboo from Igor, or rather its power-hungry transformer, and a chamber heater installation for our Sovol SV08 Max. You won't want to miss those. If you enjoyed this deep dive, check out our original review of the Toocaa here, or our recent 3D printing adventures here. So, go laser cut? No? Go print 3D. Thank you for watching another gerGO Print 3D video all the way to its end. Godspeed.